And we begin heading into the final stretches of this exam paper. Question 17. Each day, the probability that Gail does not receive any post is 0.18. Work out the probability she receives no post on 2 consecutive days. So what I'm doing there basically is looking at the probability that she doesn't receive post on day 1 and the probability she doesn't receive post on day 2, and both of those are 0.18. And because it's one of those things happening and the other, I multiply them together. So I have 0.18 multiplied by 0.18, which is 0.18 squared, giving me 0.0324 as my answer. I could think of that, if you want, as a probability tree: post, no post, post, no post, post, no post, and all I'm doing is multiplying along the no post route, 0.18 times 0.18. Part B, work out the probability that Gail receives at least one item of post over 4 consecutive days. Well, I could work out that she receives an item on day 1, an item on day 2, an item on day 3, an item on day 4, and then an item on day 1 and 2, day 1 and 3, day 1 and 4, day 2 and 3, day 2 and 4, day 3 and 4. But that would take absolutely ages. So I must think, well, it's 2 marks, it's got to be an easier way to do this. And there is. I think, what is the complement of receiving at least one item of post over 4 consecutive days? Well, it is, of course, not receiving any post over all 4 of the days. So the probability of no post, therefore. And what I know is that the probability of getting at least one item of post adds the probability of getting no post must add up to 1. That is, they're the only 2 possible outcomes. So I'm going to do 1 subtract the probability of no post to tell me the probability of getting at least one item of post. And that's good because the probability of no post is easy. It's over 4 days, so it's 0.18 to the power 4. So I'm doing 1 subtract 0.18 to the power 4, which gives me, and I'll go to 3SF, although it's not specified in the question, 0.999 as my probability. Question 18, and just looking at it, I can perhaps feel a bit intimidated, but hopefully we should be all right. I have faith in my abilities. A box is being designed to contain 4 stacks of chocolate wafers. Each chocolate wafer is in the shape of a regular hexagon of side length 3 centimetres. Each layer of chocolates fits into the box with this view from above. Find the area of the rectangular base of the box, giving your answer in square centimetres in the form k root 3, where k is rational, not necessarily an integer. So I want to find the area of the box. So ultimately, I want to find my height and my base and multiply them together. That's my aim. And the only information I have is that I have side length of 3 centimetres. So looking at my situation here, this side length 3 centimetres, well, what else do I need to know to find my height? Well, I know this and I know this. I want these heights here. And I notice they're all exactly the same height. They're all the height of this little triangle. It's quite hard to see, so I'll draw it out here. This little triangle here. I want to work out that. I'm going to call that y. I want to work out that value to give me my height. And in that little triangle, I don't know this length here, but I do know the hypotenuse is 3 centimetres, and this is a right-angled triangle. Now, at the moment, that's not enough information to solve for y. I need at least one angle or the other side. I also look at my base, and I see for my base, if I'm counting along, well, my base is actually made up entirely of these, again, these triangles, but now this length here, which I'll call x. So I have 1, 2, 3, 4, and then 5 of those x's in a row. So I've basically worked out what I'm going to do here. I need to find y and I need to find x. Because I don't know y or x, I must need to find one of the angles in this triangle. So I look back on my diagram and I think, right, well, I'm bisecting this angle here. This vertical line bisects this angle. So if I can work out the interior angle of my hexagon, then I can, my regular hexagon, then I can halve that and it'd be this angle here. So let's do that. So I know that the interior angle of my regular hexagon is 180 multiplied by n subtract 2, which is 4, divided by n, which is 6. That is, 180 times 4 is the sum of internal angles, divided by 6, because there are 6 equal angles in a regular hexagon. So I'm doing 180 times what is 2/3, so 120 degrees. And so I know this angle here is half of that, is 60 degrees. Now I can find y and x. If I'm looking for y, I've got an adjacent and a hypotenuse, so cosine 60 is equal to my adjacent over my hypotenuse. So y is equal to, and then 3 times cosine 60. You could get this in a non-calculator paper as well. We know that cosine 60 is 1/2. And equally for x, I've got my opposite and my hypotenuse, so sine 60 is x over 3, and sine 60 is root 3 over 2. So I have x is 3 root 3 over 2. So that means my height here, well, I've got this here, so I've got 3 over 2 plus 3 plus 3 over 2 plus 3 plus 3 over 2. In other words, I've got 2 lots of 3, so 6, and 3 lots of 1.5, so 4.5. So in total, my height is 10.5 centimetres. My base, I've got 1, 2, 3, 4, 5 x's. So I've got 5 lots of 3 root 3 over 2, which is 15 root 3 over 2. And therefore the area of my base is 15 root 3 over 2 multiplied by 10.5, which is 15 over 2 multiplied by 10.5, 315 over 4 multiplying root 3. And that indeed is in the form I'm asked for, where k is rational. 315 over 4 multiplying root 3. And that's quite a challenging question, but you can see hopefully through my thought processes, I'm just breaking this down into more manageable steps and hoping they come together at the end, and they usually do, and if not, I grab a load of method marks anyway.